I just want to take a minute to get us started on activity 2.1.3, which is our free body diagram activity. So when you look at number 1, we have two components here. We have the fishbowl and we have the stand that it sits on. So in order to draw the free body diagram, we have to give the free body diagram, or not give, but make a free body diagram for each component. So the first component I'll draw is our fishbowl. And we'll change that so it looks perfect. I'll call that right. And in red, I'll demonstrate our forces. Well, the first force we have is just simply the weight of the bowl, which is acting downwards. That's the force of gravity. And in order for the bowl to stay motionless, there's an equal and opposite reaction force here. We're going to call that F of the stand. So whatever weight the fishbowl is pushing down, the stand is reacting exactly opposite. So the next thing we have, our next component, is going to be the stand. And I'm going to make this a little bit finer point. So with your stand, move that down. Well, let's look from the top down. I like to look from the top down on this. So from the top of the stand, we have this force coming down on the stand from the bowl. Right? So from the top, we just have the fish bowl. From the stand itself, we also have this force of weight. So we're going to call that W of stand. So in this case, the stand actually has two forces down, one from the bowl and one from the stand itself. In order to keep the stand from moving down, or towards the center of the earth really, to counteract that gravity in the way of the bowl, we're just calling that our normal force. So we have that F sub n. And that's it. That's activity 2.1.3 number 1. We just broke it into the components, and we have the bowl and the stand separate. We're going to move to example, or problem number 2 here. So if you look at this, we have 4 components. We have log 1, log 2, and log 3, which are clear, definite, distinct components. But some people would forget we actually also have to do the stand as well in our free body diagram. So I'm going to start by just putting out number 1, log number 1. And let's talk about forces on it. Well, in terms of log number 1, we have the stand putting a force from the left, keeping it from rolling towards the left. And let's see what we're going to call that. It is going to be force of stand. And so we've accounted for the force against the log so that the stand keeps it in place from the side, but we also have force of stand from the bottom as well. And the reason I put it off to the side is we always consider that force of gravity. So I'm just going to call that weight of log 1. And I'm hoping my text size as I write that is big enough everyone can read that. But again, we have the force of the stand 1 from the left. We have the force of the stand from the bottom. We then have the weight of the log itself, which is a force downward. And our last force is coming from log 2. So we have another force coming in at an angle, force of log 2. To get you started on logs 2 and 3, if I drew the free body diagram for 2, 3, okay, I'm not going to label everything, but I'll say that log 2 has 3 forces on it. We won't label them, but log 2 has 3 forces. Log 3, similar to log 1, has 4 forces. So keep in mind what forces those are. When you draw your free body diagram, you're just going to need to include the labels on those forces. The stand itself, if I were to draw the free body diagram for the stand, something like that. Actually, let me make that a little bit wider. And again, I'm not going to label them, but you could see where some of our forces come from pretty naturally. Ones you may not be able to pick up on would be these bottom ones. The weight of the stand itself, you always have to consider the weight of the component you're doing the free body diagram on. And then you also then, here I will label this one just so you don't forget. We have the weight of the stand and the force normal, which would be, assuming this stand is on the ground, this force normal is basically just the ground pushing back on the stand so that it doesn't sink into the ground. So when you do question 3, it says draw a free body diagram for the 5 labeled parts. So you're going to have a free body diagram for the ring. Let me title that ring 1. You're going to have a free body diagram over here, which is ring 2. You'll have the cable 1 as a component. You'll have cable 2 as a component, and then you'll just box that in as stoplight. So within these components, consider the fact that ring 1, ring 2 are going to have some sort of force keeping them from sliding along this whatever component this is that it's mounted to. So you've got reaction forces there. The cables themselves, those are actually really easy. You've got your reaction forces in both directions, this way from the rings and from the stoplight. So I will check and see real quick here. There's actually just 3 reaction forces on the stoplight. I'm sorry, not 3. 3 forces on the stoplight. They're not just reaction forces. There's 3 forces on the stoplight. The other 4 components each have 2 forces. So even though I've got my red arrows on these, your job would be to label what exactly is that force. Force sub what? Force sub cable. Force sub cable. Force sub ring. Force sub stoplight. So make sure to put the arrows in your free body diagram, but please do not forget to label them as well. And then the last thing you'll do is a conclusion question, or actually conclusion questions 1 and 2 here. Answer those in your engineer's notebook as well.